Today we're going to go through lesson 5.2, which is on perpendicular and angle bisectors. And we've already done some work with perpendicular and angle bisectors, but today we're going to look at some specific theorems that relate to both of these bisectors. Your objective for today is we're going to use properties of perpendicular bisectors and angle bisectors. But the first thing I want to do is look at something from the Pearson site, and that is this solve it activity. So we're going to take a second to go through this one. You hang a bulletin board over your desk using string, and the bulletin board is crooked. When you straighten the bulletin board, what type of triangle does the string form with the top of the board, and how do you know? It says to visualize the vertical line along the wall that passes through the nail, and what relationship exists between this line and the top edge of the straightened bulletin board. Let's go to the next module and see how we can straighten that bulletin board. What must be true about the lengths of the string on each side of the nail? Well, if we slide the bulletin board, they should be the same length. And so for it to hang straight or parallel to the floor or parallel to the ceiling or however you're trying to get it to hang, then the strings on both sides should be the same length. Now let's take a look at the solution on here. And if we draw in this dashed line, which is going to end up being our perpendicular bisector because it's 90 degrees, it intersects the top of the bulletin board at 90, we will see that these two segments should be the same. And if it's the perpendicular bisector, then this part and this part of the bulletin board should be the same length. And this would be two sides, this would be one side of this triangle and one side of this triangle, and that would be reflexive. So by side, angle, side, the two triangles would be congruent. And if the two triangles are congruent, then these two sides would have to be congruent as well, which end up being the hypotenuses in both of those triangles. And there's just kind of an example or the answer that they give on the solve it activity. Okay, let's explore a little bit about the perpendicular bisectors here. And what I've drawn on here is a segment AB, and I've drawn in the perpendicular bisector, and we'll call it CD. And from what we saw in the previous slide, we can take, looks like that's going to move around on me. We can take and connect A to C, connect B and C, and because we have this reflexive piece here, we have this triangle on the left congruent to this triangle on the right by side, angle, side. Therefore, by CP, CTC, remember the congruent or the corresponding parts of congruent triangles are congruent, we could say that this segment and this segment must be the same. So what we're setting up is theorem 5.2, and we're going to look at that in just a second, which says any point that's on this perpendicular bisector, like this point C, it is going to be the same distance from A, one endpoint, as it is from B, this endpoint. That's the theorem. So if I picked a point here and I called it point F, then the distance from F to B and the distance from F to A will also be the same. Any point that I choose on this perpendicular bisector will be the same distance from A as it is from B. And here's the two theorems. These come out of your book. They come from the key concepts. This would be something good to pause the video and get into your notes. And that is theorem 5.2, the perpendicular bisector theorem. And then theorem 5.3 comes off of that. 5.2 is what we just talked about. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. 5.3 is the converse, and that says if a point is equidistant from the endpoints of a segment, then it has to be on that perpendicular bisector. So take a second and write these into your notes, and we'll explore these a little bit more. All right, let's take a look at an example of some of the problems you're going to see in your homework. And I'm going to just let this module play, and I won't try and talk over it.
In this problem, you will use the perpendicular bisector. What is the length of segment AB? Segment BD is the perpendicular bisector of segment AC. How do you know segment BD is the perpendicular bisector of segment AC? The markings in the diagram show that segment BD is perpendicular to segment AC at the midpoint of segment AC. Point B is equidistant from point A and point C by the perpendicular bisector theorem. Use the perpendicular bisector theorem. Substitute 4 times x for the length of segment BA and 6 times x minus 10 for the length of segment BC. Subtract 6 times x from each side of the equation. Divide each side of the equation by -2. Now find the length of segment AB. Substitute 5 for x. Simplify by multiplying. So, the length of AB equals 20.
Now, angle bisectors are very similar, and we have a very similar theorem that goes with angle bisectors as well. But remember what we know about angle bisectors. Let's say I've got the angle PQR, and QS is the angle bisector of PQR. So if it's the angle bisector, then that angle is congruent to that angle. That's what it means to be an angle bisector. Now here's where it's going to be a little different. What we're going to do is we're going to find how far is it from the point S, which is right here, how far is it from S to each side of the angle. To do that, this takes something we haven't talked a lot about, and that is to get from S to the side PQ. Imagine that you were standing here at S and PQ were a road, and you had to run to the road as fast as you could. You would want to take the shortest distance to get there. And the shortest distance from point S to this side is going to be at 90 degrees. So if I drew from S to the side PQ, I would want to make sure that I got there the shortest route. It was going to be at a 90-degree angle. And the same thing here, if I was to go to QR, I would also make sure that I went at a 90-degree angle. Because as you can see, that would be a much shorter route than running from S to the road maybe this way or this way. The shortest distance from a point to a line is this 90-degree angle. Now let me take those out of there. And now what have we made? We've made a couple triangles. I'm going to put a 90 here and a 90 here because they're linear pairs. And so I have this triangle and this triangle. I have the side QS. That's a part of both triangles. So by the reflexive property, they're equal to themselves, or SQ is equal to itself. So I have this triangle, and I have angle, angle, side. And in this triangle, I have angle, angle, side. So the two triangles are congruent by angle, angle, side. And if the two triangles are congruent, that means all their corresponding parts are. So from S to A is the same distance, or I'm sorry, from S to this side PQ is the same distance it is from S to the side QR. So these two lengths are the same. So it's a long way of getting there, but any point that's on the angle bisector is the same distance from each side. If I had a point out here, we'll call it J. Then the distance from J to one side of the angle is going to be the exact same distance as from J to the other side of the angle. So any point that lies on this angle bisector is equidistant from the two sides of the angle. And that's going to be the next theorem, which is theorem 5.4. So here's theorem 5.4, the angle bisector theorem, and then the converse of 5.4, which is the converse of the angle bisector theorem. 5.4 says if a point is on the bisector of an angle, then it's equidistant from the sides of the angle, and we just did that in our picture. The converse says is if we have a point that is equidistant from two sides of an angle, then it has to be on the angle bisector. And we'll take a look at a problem here that shows that.
In this problem, you will use the angle bisector theorem. What is the length of segment RM? What do you know? You know that ray NR bisects angle LNQ. You also know that segment RM is perpendicular to ray NL, and segment RP is perpendicular to ray NQ. What do you need? You need to find the length of segment RM. What's your plan? Use the angle bisector theorem to write an equation you can solve for x. Use the angle bisector theorem. Substitute 7 times x for the length of segment RM and 2 times x plus 25 for the length of segment RP. Subtract 2 times x from each side of the equation. Divide each side of the equation by 5. Now find the length of segment RM. Use the information from the diagram. The length of segment RM equals 7 times x. Substitute 5 for x. Then simplify. So, the length of segment RM equals 35. How can you use the expression given for the length of segment RP to check your answer? Substitute 5 for x in the expression 2 times x plus 25 and verify that the result is 35.
Okay, if you haven't done so, make sure you get theorems 5.2, 5.3, 5.4, and 5.5 into your notes so that you have them. They're going to be pretty valuable as we move through the rest of this chapter. So that's lesson 5.2, dealing with perpendicular and angle bisectors and how to use them. And hopefully that objective of using properties of perpendicular bisectors and angle bisectors will help you through your homework. Your homework is on Math Excel, lesson 5.2, and we will work on it today in class or tomorrow in class, depending on when you're watching the video.